Yeah? What are these holes?
Oh, great question. Have you noticed anything coming out of some of those holes?
Water?
Yeah, these are clam holes. So down beneath in the mud there are clams living, and they feed on plankton. So when the tide comes in, they pull water in, they filter out the plankton, and they spit the water back out. And when the tide is out and they burrow down deeper in the sand, sometimes they squirt that water out. So sometimes we see that on the beach, but right next to that hole is something else that reminds me of a really interesting relationship. And this is a predator-prey relationship. So this is evidence of something that eats those clams. This is the egg case of a moon snail. So moon snails eat clams. And first I want to look a little bit at the moon snail egg case, and then we can talk about how they eat the clams, because that's amazing. But these moon snails crawl through the muddy sand, and they use a special sort of glue almost to make this case around their eggs. And if you open it up and look really carefully, you can actually sometimes see hundreds of little tiny eggs in there. So one female moon snail lays hundreds or even thousands of eggs in these sandy collars, and the sand helps it camouflage and also helps protect it from drying out. But the other evidence I see of moon snails are these shells with perfect holes in them. And this tells us how the moon snail eats. So that moon snail comes along and it finds a clam or another bivalve. They really like to eat things with two shells, like clams and oysters and mussels and cockles and other bivalves. That moon snail comes along, it kind of has this really strong foot that it can suck around the clam and hold it in place, and then it uses a special tongue called a radula, and it drills through the hard shell of the clam. It releases some digestive juices, sort of like our stomach acid, turns the clam into a liquid, and slurps it all out. So if you see shells like this on the beach with a perfect circle, you know that a moon snail or another predatory snail like a dogwinkle has drilled through and eaten out what's inside. And I bet you can find some other perfectly drilled shells around here. But that's an example of a predator-prey relationship, and that is definitely a happy face for the moon snail and a sad face for the clam. So it's not like a mutually beneficial relationship. It is bad news for the clam when that moon snail comes along and starts to drill into it and eat its insides. Cool. While we were out at the beach, we didn't see many obvious signs of parasitism. That's a relationship where one organism benefits and one organism is harmed. So it's a smiley face, sad face relationship. One example that I did notice was a type of algae, this red algae, that had another parasitic algae or an epiphytic algae growing on top of it. And so this is a picture of the algae without the parasite on it. And in these next two photos, you can see a little bit of that kind of fuzzy parasitic algae growing on top of the host and a lot of that fuzzy parasitic algae growing on top of the host. And the parasitic algae benefits from this because it finds a place to attach to, and it's able to get closer to the sunlight coming down through the water, so it's able to photosynthesize more. But this hurts the host because the host gets less of that sunlight. It's being captured by the parasite instead. And the more of that parasitic algae that grows on there, the more vulnerable the host is to being torn off or damaged by waves because there's more of it or its parasite to get caught and dragged along by the wave. So this is an example of a parasitic relationship. Another example that you might be familiar with would be mosquitoes and humans. So for us, we're harmed by this relationship because we have those itchy bites, and sometimes the mosquitoes can carry disease as well. But the mosquitoes benefit. They are getting nutrition they need by biting us. And so that's another example of a parasitic relationship.